Hello everyone, welcome back. Now today I'm gonna work on a setup on a new sensor that is MXC6226XU. To have a knowledge about this sensor and to see it, let's have a look over the website controleverything.com and here search for the relevant sensor that is MXC6226XU. Now as you can see, this sensor is a digital thermal orientation accelerometer. It's a 4 position orientation detection and shock survival, greater than 50,000 G fully integrated thermal accelerometer, and a lot more features are being provided. As you can see, now you can purchase the sensor from the website and here it is. Now I'm gonna interface the sensor MXC6226XU with a Raspberry Pi and a Java code. Furthermore, to have this code, go to Resource tab and here comes the Java code sample. Now you can download the Java code sample as zip file from this very link. Here it is. And you can also have the opportunity to download the code from github.com and the repository that is Control Everything community. Now I will have a look over the hardware connections which we will work out and see again. Now this is the sensor we are looking forward to explore, that is MXC6226XU. It's a digital thermal accelerometer. Now we want to connect it with a Raspberry Pi which is here as you can see. Now I want to make a connection among the sensor and the Raspberry Pi, and for that I require an I2C shield which is available on the website controleverything.com. The reason why we are using this I2C shield is to make connections with other I2C devices and rather make them easy. So gently place the I2C shield over the GPI pins of the Raspberry Pi. And for making a connection among the sensor and the I2C shield, this here a connecting cable comes into the picture, and now gently connect over to the sensor. And while making this connection, make sure that the ground terminal of the sensor should be connected to the ground wire of the cable, and hence we have to be sure for I2C shield also for the same. Now we want to make the power up connection for the Raspberry Pi, and here comes a micro USB cable, and gently insert it over the power jack and light it up. So finally we need to make an internet connection for the Raspberry Pi, and for that we require an Ethernet cable which you are able to see on my screen, and gently insert it over the power jack. Now in case if you don't have this, you can also use a wireless nano adapter. It's very useful and it might save you day also. Now what do we require is a code so that we can interface this with the sensor and the Raspberry Pi, and let's see what we got there. Now we want the Java code so that we can interface our sensor. So for that I have to log into github.com and here search for the repository that is Control Everything community. Now let's have a look over that, and here type in the sensor name MXC6226, and here we get our sensor. It's a digital thermal orientation accelerometer, and here comes the Java code. Let me show you the instructions first. We have to download and install Pi4j library on the Raspberry Pi, and this is the link. Pi4j.com is the link from where we can install the Pi4j libraries. All the relevant information is being provided, commands are there. So note it down carefully and get it done. After that we have to compile the Java code, and after that this is the command to run the Java code. Note it down, and now let's have a look over the Java code, which is a .java extension file. I will be explaining line by line. So first of all we have to import the Java header files which we have done, and you can see the public class creation named MXC6226XU, and the address of the device is 0x16 as you can see. After that the writing command comes, it says that we have to select detection register having address 0x40, and we have to power up command that's 0x00. After that the device will send data back which we have to catch up, and it says that we have to read 2 bytes of data, and it's from 0x00. It's XY axis, and here comes the conversion of the data for XYX acceleration. After that we have the data displayed on the screen in the form of acceleration which is in X and Y axis. It's a %d formation, and format is good. It's raw values as you can see, and it's all in the code of the Java. Now what we require is to see the practicality of this code. Let's have it. Well, this is interesting. Let's have a look over the practicality of this code. So for that, copy this entire Java code. Now open up the terminal for the Raspberry Pi through internet, and as you can see, I've created a new file, MXC6226XU with .java extension file. And here we go. Here paste the entire code and save it. And this is the command to compile, as you can see on my screen. And here we go. It's good to go. Now this is the command to run the Java code, and here are the values of acceleration in y-axis, x-axis and y-axis. So when I send it again, there will be a small change in the values, as you can notice. Now what do we require is to move this sensor a little bit so that we can notice the changes in the acceleration, which is clearly visible on the screen. Now when I'm trying to move it again and again, there will be changes in x-axis acceleration and y-axis acceleration data again. So this is how the code works. So let's have a look over the benefits and features and the working environment along with the applications of this sensor. The sensor MXC6226XU is a MEMSIC digital thermal orientation sensor. DTOS is the world's first fully integrated orientation sensor. Its operational is based on the patented MEMS thermal technology and is built using a standard 0.18 micrometer CMOS process. DTOS contains no moving parts such as a ball and thus eliminates field reliability and repeatability issues associated with competitive products. It also eliminates the click sound typically heard in all ball-based orientation sensors. Shock survival is greater than 50,000 G. So due to these features, it's applicable like applications which are cell phones, digital still cameras, digital video cameras, LCD TVs, toys, MP3s, MP4s, fan heaters, cooling fans, and a lot more. Now you can purchase this sensor and it's available on the website controleverything.com, as you can see, and you can get the code from the resource tab. After that, you can download it. You can also download the code from GitHub repository, and the it's called Control Everything Community. Now for relevant questions and any frequent queries, you can contact us on controleverything.com, and you can post your queries on the community page. To have blogs, articles which are relevant to this video, you can go to instructables.com and search us for this. Now, if you want more videos like this, you can subscribe our YouTube channel. At the very end, I would like to make it clear that for any queries, you can contact us on controleverything.com and you can fully understand any part of this video or sensor. Now, I hope you have a good day and you enjoyed this video, and a lot thanks for watching.